Now, still on Fourier cosine series, we have this question to solve, which is find the Fourier cosine series for the function f of x is equals to 1 between the range of 0 to 2 pi and 0 between the range of pi over 2 to pi. Now, since in Fourier cosine series, we know that our formula for f of x is equals to a naught plus summation a naught over 2 summation n is equals to 1 to infinity of an cos nx, because b of n is equal to 0. And these are the formulas to use for a naught, and these are the formulas to use for an. Now, this looks like non-periodic Fourier function because it is discontinuous from 0 to pi over 2 and from pi over 2 to pi. However, it ranges from 0 to pi. So, with that done, let's start with a naught. A naught is 2 over pi from 0 to pi f of x dx. Now, since we have two limits, we have from 0 to pi over 2, and we also have from pi over 2 to pi. So this can be reduced further, and we say a naught is 2 over pi integral of 0 to pi over 2 f of x dx plus 2 over pi integral of pi over 2 to pi f of x dx. Now, we have 2 over pi, 0 to pi over 2. Then the question is, what is f of x when we have a limit of 0 to pi over 2? F of x in that case, between 0 and pi over 2, f of x is 1. So we have f of x to be 1 dx plus 2 over pi integral of pi over 2 pi. For the range of pi over 2 to pi, what is f of x? The range of pi over 2 to pi, f of x is equals to 0. I'll give us 0 dx. Anything multiplied by 0 will give us 0. So we are left to solve with 2 over pi integral of 0 to pi over 2 of 1 dx. So integrating 1 give us x. So we have 2 over pi from x from the limit of 0 to pi over 2. So a naught, let's apply our upper limit minus lower limit. A naught is 2 over pi. The upper limit is pi over 2 minus the lower limit is 0. So this means that our a naught is equals to 2 over pi multiplied by pi over 2. So a naught is equal to 1. So with that done, we can move further and evaluate an. Recall that an is 2 over pi integral of 0 to pi f of x cos nx dx. Now, since we have 0 to pi over 2, and we also have pi over 2 to pi, we can split this, and we say an is 2 over pi integral of 0 to pi over 2 f of x cos nx dx plus 2 over pi, and now the next limit, that's pi over 2 to pi f of x cos nx dx. Now, like we did when calculating a naught, 2 over pi integral of 0 to pi over 2. What is f of x when we have limit of 0 to pi over 2? And the answer for 0 to pi over 2, f of x is 1. And for pi over 2 to pi, f of x is 0. So therefore, we have this to be 1 cos nx dx plus 2 over pi integral of pi over 2 pi, and this to be 0 cos nx dx. Anything multiplied by 0 will give us 0. So we are left with an is equal to 2 over pi integral of 0 pi over 2. Since it is a multiplication by 1, we are going to have cos nx dx. Now integrating cos nx dx, we have that an is 2 over pi, and integrating cos nx with dx, we have it to have sine nx over n from 0 to pi over 2. Now an is equal to 2 over pi. Then we put the upper limit and subtract it from the lower limit. We have sine n pi over 2 over n minus the lower limit of 0, sine n of 0 over n. So we can evaluate our an to be 2 over pi. Now, okay, limit of 0 to pi over 2. Now we call that sine pi over 2 is equals to plus 1. Okay, so sine n pi over 2 can be plus 1 or minus 1. Okay, depending on either when n is even or odd, because we know that sine 3 pi over 2 is equal to minus 1. Okay, and okay, so remove this. Sine pi over 2 is equals to plus 1, and sine 3 pi over 2 is equals to minus 1. However, sine pi is equal to 0, and sine 2 pi is also equals to 0, and sine n of 0 is 0. So we can evaluate this, give us 0, and be left with this alone. So we have it to be sine n pi over 2 over n forms. We have included our limit already, so I think this will not be there. So at this point, we can now evaluate our a1, a2, a3, a4, and a5. Can choose to stop at 4. So a1 is 2 over pi, so we are considering this formula, and wherever we see n, we change the value. So a1, n is equals to 1, so also sine 1 pi over 2 over 1, n is 1. So we have it to be 2 over pi, and sine pi over 2 is plus 1 over 1. So our answer will be 2 over pi. Now a2, 2 over pi into sine 2 pi over 2 divided by 2. Remember, we are following this formula. So this will give us 2 over pi sine 2, this 2 into pi over 2. Remember, 2 will cancel 2 and we left with sine pi. So sine pi is 0 over 2, and this will give us 0. A3, that means when n is 3, we have 2 over pi multiplied by sine 3 pi over 2 over 3. This will give us 2 over pi. Sine 3 pi over 2 is what we have here, to the minus 1 over 3. So this will give us minus 2 over 3 pi. Now A4, that means n is 4, and we are going to follow this formula that we have here. That's an is equals to 2 over pi sine n pi, so we change it to sine 4 pi over 2 divided by 4, and we have 2 over pi sine 2 pi over 4. Sine 2 pi on its own is 0. So we have 2 over pi divided by 0 over 4, and this will give us 0. Finally, A5, 2 over pi, and wherever we see n, change it to 5. So we have 2 over pi divided by sine 5 pi over 2 divided by 5. So press our calculator, we will see that sine 5 pi over 2 is 1. So we have 2 over pi multiplied by 1 over 5. Give us 2 over 5 pi. So in conclusion, our A1 is 0. Our A1 is 2 over pi. Our A2 is 0. Our A3 is minus 2 over 3 pi. Our A4 is 0. And our A5 is 2 over 5 pi. So in essence, recall that our A naughts that we evaluated before, okay, our A naughts that we evaluated will be 1. So we recall that A naught is equal to 1. And the formula for the Fourier series f of x is equals to A naught over 2 plus summation of n is equals to 1 to infinity of an cos nx. This is Fourier cosine series because bn is equal to 0. So we can split our an to give a1 cos x plus a2 cos 2x plus a3 cos 3x plus a4 cos 4x plus a5 cos 5x. So when we substitute our values for a naught is 1 over 2, a1 is 2 over pi cos x, a2 is 0 cos 2x, a3 is minus 2 over 3 pi cos 3x, a4 is 0, and a5 is 2 over pi 5 pi cos 5x. So we can simplify further, and we know that our final answer for the Fourier cosine series will be 1 over 2 plus 2 over pi cos x minus 2 over 3 pi cos 3x plus 2 over 5 pi cos 5x. Because this will cancel out to 0, cancel out to 0. So we have been able to solve 2 questions on Fourier cosine series. Now we want to go, our next video will talk on solving questions on Fourier sine series. On Fourier sine series.